video tutorial to help you with Chapter 13 of AP Statistics Experimental Design. An experiment is a study design used to show the difference between two treatment groups. Today we're going to show you an experiment by conducting a taste test between the difference in Coke and Pepsi.
There are 4 principles in experimental design. The first principle is control. This occurs when we control the sources of variation that can negatively impact the conclusion of our experiment. We must make conditions similar for all of our treatment groups. The second principle of an experimental design is randomization. This allows us to equalize the effects of sources of variation that are either unknown or uncontrollable.
The third principle of a design is replication. An experiment won't be effective if you only have one person coming up. So in order to enforce that we have replication in our experiment, we have many people testing whether or not they like Coke or Pepsi. The fourth principle of an experiment is blocking. It's optional, but it does help the effectiveness of preventing bias from happening in your experiment. Blocking is when you group similar people together. So in this experiment, we are going to group people that say they prefer Coke together and put them in a group, and then group the people that say they prefer Pepsi better in a group with themselves.
We also blind our experiment to prevent any response bias between people who previously preferred Coke or Pepsi. Our experimental units will not learn whether they are drinking Coke or Pepsi until after the experiment. This is called single blinding because only they are unaware of the type of drink they are consuming. In a double blind experiment, not only would they not know, but we also wouldn't know what soda they were consuming.
Which do you prefer, Coke or Pepsi?
By determining one's preferences, we gather the information needed to block our experimental groups based on a preference of either Coke or Pepsi. This helps to prevent bias in the experiment based on one's preconceived soda preferences. Bias in an experiment would lead to an inaccurate representation of the population and ruin the experiment. Each person who takes part in our experiment is referred to as an experimental unit. And each of our experimental units either undergoes the treatment of consuming Coke or Pepsi. As one can see, by utilizing many volunteers, we fulfill the requirement of replication, which allows us to minimize the variation occurring within our experiment and fulfill the principle of replication.
Yeah, say that on video.
I like Coke.
Our random volunteers from each class helped us to minimize sources of variation that were uncontrollable,
Are you friends with her? Try her drink, see if you can taste it.
such as a difference in age level which could affect one's preferences between Coke and Pepsi, which could potentially interfere with the outcome of the experiment. Now, let's observe all principles working together in our experimental design.
Coke or Pepsi? Coke or Pepsi? Smells like Pepsi. Pepsi. Coke or Pepsi? Pepsi. Okay, take one. And is it Coke or Pepsi? Coke. Coke or Pepsi? Okay, take one. And is it Coke or Pepsi? Pepsi. Coke or Pepsi?
Now let's observe a possible error in experimental design.
Okay, so you like Pepsi, so just pick anyone you want. It's Coke.
Really?
Number one.
Really?
Number one. The one splash mark Coke. Oh, yeah, you can't do it. No, now you can't do it.
Here, one of our participants became aware on how to tell the difference between the Coke and the Pepsi, ruining the blinding of our experiment.
Tell me what you prefer, Coke or Pepsi.
For Coke.
Okay, take a cup.
Well, I can see there's a difference in color.
But you don't know that.
In this instance, someone observed the difference between the coloration of the Coke and the Pepsi, allowing them an unfair advantage in determining what the soda they were consuming was, and revealing a source of error.
For Coke or Pepsi? Okay, take a cup. And do you think it's Coke or Pepsi? It's Pepsi. Coke or Pepsi? It's Coke. Okay, take a cup.
Oh, we know. We'll tell you. I'll tell you when it's free.
Coke or Pepsi? Coke.
Everyone
Coke or
and
Pepsi? Okay, take a cup.
Remember the 4 principles of an experimental design: control, randomization, replication, and blocking, which is optional. If your design fails to include the 3 necessary components, replication, control, and randomization, your design will fail.